Hello, everyone, and welcome to today's webinar. I'm Robin Carr, and I'll be your moderator for today's event. Thank you for being here. We're going to wait just a moment and give everyone an opportunity to join the webinar. We'll get started momentarily. All right, everyone. Thank you for joining today. Before we get started, I have a few housekeeping items to go over. If you lose audio or visuals, simply exit GoToWebinar and come back to reset your connection. The chat feature is available in your GoToWebinar menu panel and should be used only for general comments or requests for technical assistance. You can ask questions using the questions feature available in your GoToWebinar menu panel as you think of them. Don't worry, put your questions in as they come to you, and at the end of the presentation, we'll have a Q&A session. We also have a handout for you today. In the handout section of your GoToWebinar menu, there's a PDF version of today's presentation deck. You can download that at any time during today's event. However, it will not be available once we close this event. So be sure to download that while you're here with us. The presentation is being recorded and will be available on our Fluke YouTube channel within the next few business days. We'll hear from our speaker, Chuah, and if there's time, we'll go into a Q&A session and we'll answer as many questions as we can. Don't worry, post those questions. We'll do our best to get to all of your questions. So as I mentioned, our speaker today is Chuah. Keith is a sales and application engineer at PRUFTECHNIK, a division of Fluke Reliability. Keith brings over 5 years of experience in technical sales and 3 years at PRUFTECHNIK, if I can speak today, with a strong background in the rotating equipment sector spanning 11 years. Keith specializes in providing solutions that enhance machinery reliability and performance through advanced condition monitoring and laser alignment technologies. He is dedicated to helping clients optimize their operations by leveraging his technical expertise and innovative tools. All right, everyone, you're here today for adaptive alignment, solving every shaft alignment challenge. Keith, take it away.
Hello. Hi. Good morning, good afternoon, and good evening to everyone. I think it's a global webinar. So yeah. So my name is Keith. Thank you, Robin, for the introduction. Yeah. Just to for what you have saw from the slides. Okay. I've actually just do a slight update on the 2 years difference, if you can see just now. Yeah. So again, I'm actually from the pump industry. I started my career from pump industry. So just to introduce a bit, right? And yeah, being said that, right, I've been dealing with rotating equipment since graduate, and yeah, then I've known PRUFTECHNIK, or now under Fluke Reliability itself. The brand of PRUFTECHNIK has been in my mind for almost more than 10 plus years. Yeah. So since the day one that I've been in the rotating industry. So yeah. So as for today, so what we are aiming, to share to you or to give you a good a journey of experience in our reliability solutions, right? We will head on to the topic for adaptive alignment. Yeah. So okay, moving to the next slide, right? So I just want to give you a quick introduction also about where we are as Fluke Reliability, right? So PRUFTECHNIK, right? We joined the Fluke family, right? About 4 years plus ago. And being said that, we have world-class hardware, software in PRUFTECHNIK itself. We are giving solutions in laser shaft alignment, condition monitoring, and also the NDT, non-destructive test section, right? And I'll give you a brief more into it in the next few slides. And of course, we did welcome eMaint, and of course our latest family member into Fluke reliability. It's Azima DLI. So yeah, so a quick one on both of the new I would say family members also, right? eMaint, they are actually expert in the software part or the CMMS part, right? Which is considered the computerized maintenance management system. So they have been with Fluke reliability not for quite some while, all right? And in terms of what they do is they're helping organization to plan, track, and also execute maintenance, preventive maintenance scheduling, right? With the tools for mobile access, it enables to manage maintenance tasks in the field and online or even offline, right? So yeah, and yeah, just to mention, right? So excuse me. So the Azima DRI, right, which is acquired roughly just a year plus ago with us, right? And yeah, so a brief about them is that they are also the leader in the AI-driven vibration analysis and remote condition monitoring, right? And of course, the product, right? The brand itself offers the names such as the Watchman 360 platform, and of course it uses sensors to monitor machine vibrations, identifying abnormal patterns and signals that potentially create issues like bearing wear or pump cavitation and so on and so forth, right? And of course, this approach, right, is powered by AI, and it does help in industrial users to predict equipment failures and allowing timely maintenance, and reducing unplanned downtime, and also which is especially valuable in manufacturing sectors with complex machineries, right? All right, so just to move on a bit, right, to the next slide. In Fluke reliability, right, we create a unique proposition, right? So as per mentioned earlier, we bring out the three brands itself, namely PRUFTECHNIK, eMaint, and Azima, right? And in that ecosystem, right, we try to create an enhanced system, right, where machineries and team collaborate using a one-stop solution, right? And also it's to mention it's a sense for connected reliability, which the ecosystem lies in its potential. We are paving way for the AI-enabled prediction functionalities, which it spans through all across PRUFTECHNIK, eMaint, and also the Azima, right? And yeah, dealing with the data acquisition, and yeah, of course, leveraging automated analysis. Then we'll look through the next few slides. I'll bring you through more on that journey. All right, so yeah, let's move next. So yeah, this is our goal, this is our mission, and one shared purpose, right? So our goal, right, is to simplify connected reliability solutions for the people who keep the world up and running, right? So this is our this is our main goal, which we aim to provide to our users, right? And with that said, right, let's move on to this particular information or slides which I want to share to you, the 5 pillar, all right, the 5 pillar of connected reliability. All right, we do have the first of portion, which is install, acquire, enrich, act, and of course another one which is the shared services, right? All right. So today's focus, right, what you see, I will be more focused on the install portion, right? So it is actually more on the peak performance from day one, right? So let's look deeper, right? As you can see, for the first portion, which is the install, the bottom part of it are our products and our solutions, right? So we do have, of course, our main topic today, which is the adaptive alignment, which is related to the laser shaft alignment, right? And we have different ranges to cater all different level of complexity from the users, right? We have our basic range, we have our mid range or the standard range, and we also have our advanced range of the shaft alignment, which is known as the rotor line, right? And of course, we do have also the rotor line series on the intrinsically safe portion, right? Which is the rotor line touch EX. And of course, moving down to the active situation intelligence, it is part of the software part, which is also built into the device, or we call it the CPU of the shaft alignment tool, and also the software, which is we known as the ARC, or Alignment Reliability Center, which is also available. If you can download from our website, you can do some trial, some demo using that portion, right? So yeah, this is one of the portion I will touch base later on also. And moving next is the geometrical alignment, right? So you know, in this whole solution that we are trying to provide to our end users, in fact, our shaft alignment tool, right, which is related to the laser and sensor, typically on the rotor line touch series, which is a sensor line 7, we are actually able to use it to function in a way to check geometrical alignment also, such as flatness and ball aligns, simple ball aligns, and of course straightness. Yeah, so all these are down to the geometrical alignment portion. And of course, if you can see my mouse pointing to this I will call it a liver line expert product, right? This is actually also a self leveling product, which is for the mainly for the leveling checkness, and also it can beam up to 100-meter in distance, right? In one distance, right? So right, and next to it is the software that complements the geometrical alignment. And the software itself is the one that generates the report for your end users or your clients. And of course, by saying that, right, so this is what you see in our whole alignment systems, where it combines the hardware solutions and the software solutions into it's just that alignment portion itself, right? And of course, last but not least, we do have another laser pulley alignment tool, which is called a pull align, right? As to share, right? And those are basically for the installation portion, right? And let's move next. Yeah, on just a brief one on the acquire. So when we already you know, done the alignment, right? Of course, when the job of alignment is done, we also you know, have a solution, you know, to connect how to connect all these portions from the install to the enrich, right? So we have the acquire portion. So this acquire purpose, right, is to gather data, right, to support your analysis, right, such as what? For instance, after the alignment, we have the report. So the report, right, such will be also combined with all those information like the temperature, or vibration, electrical signals, and also lubrication, and all those data, right? They are enriched and also combined with our PRUFTECHNIK or solutions in our vibrations. We have tools as you can see right below, right? Which is our route based and to permanent sensor solutions, right? And of course, from the left-hand portion of the graphic that they can see, okay, we have basic, simple equipment tools. And moving to the right-hand side, we are getting more complex, right? And of course, I didn't mention about these multiple P&F curve, right? So basically, this P&F curve refers to the potential failure curve, where just to share, in case you may not know, it refers to basically what we address as every equipment or every tool or every even running assets, right? They will have their lifetime, right? But our intention, right, of knowing this PNF or potential failure curve, right, which we can study further, from our other webinar sharing, is that it gives you, a lifetime kind of a thing, a curve on any products that it shows that from start to the end of a product, right? You can actually use our tools or our supporting tools, right, to prolong or to enhance the life of the machineries, right? So how do we do it, right? So this is where we come from, right? On the vibration portion. So we have our basic portable handheld tool, such as the Fluke handheld meter, and also we do have our black color portion. If you can see my laser pointer here, we have our whip scanner 2 product. We have our Whip Expert 2, and also, of course, our Whip Guard, which is the online solution, and also our wireless sensors products to support, right? And being said that, the bottom part of it, this one I'm sharing, is the EX version of our portable tool, right? And of course, let's move next after the acquire. Of course, how we want to enrich, right? Those data, right? So yeah, of course, we do have all these informations. How are we gonna gather these, and how are we gonna assist an organization, right? From the reliability team to the maintenance team, how are they gonna be fit with all those information? So this is where the enrich part comes in, right? We have the asset registry, user management, we have device management, configurations, trendings, alarms management, visualizations, and analytics. All these are combined into one solution, into what we call, as you can see, the e-main portion, right? So we have our e-main CMMS software to help facilitate all these things, right? And it creates work orders for end user to do the next step, which is the act part, right? So that when you look at the act portion, right, yeah, that is where we have our CMS tool to support it, right? And yeah, so this is one of our solutions, right, to empower, right? And the act portion is the the action of doing rectification, right? And how these rectifications of the or the decisions being done on the machineries, on the maintenance, right, is all supported, right? And by all the data drivens, which is from the enrich part, which is the analytics, right? So all these informations are backed up into a solid action. And when these actions are done, they are all the tasks and all these traceabilities are all recorded. Yeah, it's all recorded through this our software, right? So this is something that is more is very enhancing, and it creates smoothness in your day in day out maintenance job also, right? And of course, the last portion of it is the connected knowledge services. So we do have active assistance. What does it mean, right? In our service portion, right, we have our on-site machinery services. What we do is we have central line services, we have shaft alignment services, we have vibration services, whether it's offline or online. Yeah, we typically conduct what we call remote condition monitoring. Of course, we do go on site for vibration diagnosis, including in situ balancing, or we call it a field balancing, right? And also, not to mention, we have our parallel services, right? This is we call it a roller alignment service, where the product is not sold. Of course, it is duly owned by PRUFTECHNIK, where it is typically done on professional services, right? It is done on paper and pulp industries, those that have rollers, right? Multiple rollers, right? You can perform that kind of parallelism kind of services, right? Right. And moving on, the next portion, which is the on-demand expertise, we have our training portions, which I will also highlight in almost at the end of our slides to share all the available courses that we do have, right? And whether it's online or face-to-face with our trainer, and of course we have our reliability program consultations through our professional services teams, right? Right. So next, right? Let's move on. To the adaptive alignment, right? When we talk about adaptive alignment, okay, so we will have to brief you a bit in case some of y'all may have known what is shaft alignment, but bear with me. I will have to go through just in case we have some new people that haven't jumped into perhaps laser shaft alignment world. This is something that I would like to share a bit portion about what is shaft alignment, right? So in a very brief portion, right? So shaft alignment basically is at the point of power transfer from one shaft to another shaft, right? So the one shaft is referring to the one that gains the power first, which is typically the motor part of it, right? And then the power transfer to the pump, right? So and the axis of rotation, right, of both shafts, okay, should be collinear. So at the straight line, right, collinear at certain tolerance. So why we need a certain tolerance, right? So every shaft alignment that we do, and every different sizes of machineries, of course they will have their own typical tolerance to control. So that is how we know how good is good, right? So definitely each and every equipment have its own acceptable tolerance, right? And when the machine is running, right, the last portion of it is under normal operating condition. So these are the bolted ones that I've put in this sectors. These are the ones that the criteria should fit, right, in order for us to understand what is shaft alignment, right? So under normal operating condition means that the equipment, right, should in a way it should have achieved the shaft alignment, or we call it zero shaft alignment, when it is actually running at its operating condition. Yeah, that is how the shaft alignment definition means. All right. Okay, this is one of the slides that I think it's very important to share, which I do believe a lot of our trainers or professional people in this maintenance world would definitely be interested to know also, right? So a quick study that was done, right? It's taken from a major UK chemical company, right? Is that the question is, are your machines alignment within tolerance, right? And how many are there, right? So if you can look at the right hand side, if you perform a shaft alignment within a certain tolerance, right? All right, and you can see from the diagram on the right hand side, whereby the infrared tomography, right? We will show you that there is no high transmission of the temperature. You can see, although the machine is running, right? And if you can look at the left hand side, which is if the machine is done out of tolerance, right, we notice that there is a high heat transfer, or during there's misalignment occur, then this is what the image will capture, right? And of course, statistics shows, right, that only 7% of the measured machines fall within the acceptable alignment tolerance. And of course, we have to agree that there's no ISO chart that governs, right, whether the certain tolerance is fall within is good or not. But being said that, PRUFTECHNIK ourselves has been in the industry for over 50 plus over years, right, since 1972, right? And I would probably say that we create, right, a tolerance table that in which users can use it as a guide, right? And it's based on thousands of machines, data is being collected, and we came up with these tolerance that to say that, hey, this is the right tolerance, or this is the tolerance that you're safe enough to do, that your machine will have a long prolonged life, in reliability work, right? So of course, let's move forward. We have to see, if machines are done within, we have to see the differences if the machines are done within the tolerance, what kind of outcome that it will actually provide to you, right? So yeah, so first of all, you have to look at the benefits of precision laser alignment before we look into the how adaptive is our alignment is, right? So we can notice that, right, based on the tolerance that we earlier touched base, right? If we, right, based on this offset, right, if we do a shaft alignment within a 0.25 mm tolerance, right, we can actually, right, basically introduce power consumption which is almost 0%, right, on the machine, right? And if you look down to the right hand side, right, if the tolerance is not done as within the required spec, right, and then we may incur more than 10% of power consumption. So what does it mean, right? It means that if you perform a good shaft alignment, right, you are actually able to save the energy consumption, right, or the power that is being used, right, but up to 10%. This is how how critical, right, that shaft alignment is, right, when we talk about how precise we want our machine to run within that particular tolerance, right? So this is a good example, to show you that this data supports, right, where if you perform a tolerance within a certain required specs, right, and then your alignment will affect the management's costings and down the road, right? And then of course, let's look at the next portion related to the bearing, right? These are also costs, right? So if you can see here in brief, if you perform a shaft alignment within a 0.25 an offset, right, based on offset. In fact, let's say your bearing from the manufacturer, it's supposed to run about, or it's being spec supposed to run about 10 years, right? And if you keep your alignment, or you keep the machine aligned within that particular portion, 0.25, let's say, right, based on the periodic portion, right, you can actually have the bearing life extend to 90%, right, of its life cycle. Means about 9 years, let's say if it's 10 years being spec, right? And of course, moving down the right hand side again, you're expecting to reduce the life almost half of it, right? Or actually it's half of it, 50%, right? That you're bearing within 5 years, gone, right? So this is how critical precision laser alignment means to us, right? And of course, we do have reduction on the mechanical seal repairs, and of course, we do have, of course, correlated the reduction of pump repairs too, right? All right, so let's move forward. And of course, this is what, as I mentioned earlier, I started my my reliability journey, or shaft alignment work with of course ruler and feeler gauge, right? Just run through a bit of a short history about the alignment of machines. And of course, we understand that by performing alignment based on a meter rule and also a feeler gauge, it is kind of like I would say it requires your eye power to basically see things on the meter rule, and also of course you do need to prepare feeler gauge to check in and out, which kind of thickness that fits through the gaps, right? So this I have to admit, I've gone through that portion before, and I do have to say, one thing that we are missing out is, of course, the traceability part, or perhaps if you want it to be generated in a report directly, we face a lot of this kind of requirements right nowadays. A lot of requirements need all our alignment jobs to be recorded, right? So I would feel that this is one of the portion that we are missing out, where by using ruler or meter rule and a feeler gauge, it would take you more time, and also there's a lot of I would say doubt in that also, right? And of course, the we call it the resolution, right? It's quite low, right? I'll brief you later. I'll summarize later on the next few slides, right? And then of course, moving down after the feeler and meter rule, we have the dial gauge portion, right? And of course, we do have two types. One is the rim and face method, and the other one is the reverse dial indicator method, right? And of course, both of it have its own and pros and cons, right? Of course, rim and face method, right? It's mainly, I would say, is suited on the short flex couplings, and of course, on the right hand side, which is the reverse down indicator, is more suited for spacer couplings, right? So I won't boil down too much more on the explanation. I think this is something that we have also, perhaps some of y'all have done before. Let's do a survey to check later, right? And of course, yeah, if you can see here, 1982, we introduced our very first dial gauge alignment tool. If you can see, this is our Optoline, I would say, oh, sorry, this is our, actually, it's not, it's about Airline 2000, right? Series, which is actually introduced not even from the year that I was born, actually. So yeah, in fact, you can see, there are a lot of things that we PRUFTECHNIK, have gone through the experience, right? They have gone through a lot of mechanical dial gauge issues, like such as what? Such as sagging. You can see there the sagging of the dial indicator, okay, the bending moment, a deflection, right? And of course the dial hand, right? The dial hand of it, whether it's sticking or it jumps itself, a lot of things that we may face, right? Those problems, like maybe also human error, it's obviously introduced when you are performing dial gauge alignment, yeah, and of course, we have play in the mechanical linkages, right? As you can see the linkages here, right? And there's a lot of you introduce a lot of possibilities, that your data might not be that accurate, right? So these are the things that a lot of things when you want to perform a dial gauge alignment, you have to be very professional in, right? You have to make sure this is done well and that is done well. Yeah, a lot of things, right? So yeah, so let's move forward, right? Yeah, this is the one. If you can see the next slide, some portion of the coupling play, that will also affect our alignment our procedure when you are performing a dial gauge alignment, right? And of course, moving down the years, right? Yeah, if you can see here, the logo is actually a PRUFTECHNIK DB, right? And yeah, so if you move forward 2 years later, we introduced our Optoline series, our very first Optoline series, right? And of course, a single laser double detector, if you can see here, right? Or double sensor, right? Right. So this is one of the very first laser technology that we introduced in for over more than I think 30 over plus years ago, right? So yeah, so in brief, right, let me brief it out to you, right? You can see, right, on the left hand side, straight edge, and we have as I mentioned, the resolution is down to 0.1 mm. Okay, we are talking about SI unit. or 5 mil or 5 thou. And of course, the dial indicator portion have a 0.01 mm resolution. And yeah, and all those problems that is indicated here, such as sagging issues, yeah, it's available there, right? It persists, right? And of course, we have our laser alignment, right? And where if you can see here, this is the wired type, right? And now moving down the days, we have already go on to the wireless type, right? And of course, the resolution is down to 0.001 mm or 0.05 mils, right? And of course, we need the wizard, of course, to perform this kind of alignment by using straight edge or filler gauge, right? And of course, for dial indicator, we need the specialist. We perhaps need a calculator. We need a spreadsheet, to record all those and to have it all calculated, right? This indirectly point out to taking more time, right? And of course, we look at our laser alignment technology now, we are able to give you a good idea, right, on how any technicians also can perform their job, right? So now let's move to the poll, right? Have a just quick Q&A session, right? What kind of alignment tool, right, do you most frequently use? Yeah, and I will pass it to our moderator, right? Straight edge and filler gauge, dial indicator, laser shaft alignment, or no alignment methods being used. So, yep, I will pass it to moderator, Robin.
And Keith, it's displayed right now. And I see our answers are coming in. And you should also see those answers in the GoToWebinar menu. But if you don't see those, I'm happy to tell you what the responses are and share the poll in just a moment. And hopefully you'll be able to see the poll. The audience definitely will be able to see the poll. For our audience, I'll have it up for about 15 more seconds if you'd like to vote. All right, and closing the poll now.
All right.
And there we go. 69% of our audience voted, and the overwhelming answer was 67% said laser shaft alignment.
Oh, perfect. I can see that we have quite a large portion, right, of the majority of the participants are actually already, perhaps, right? Perhaps we're already using laser shaft alignment. Of course, that would be that's a great thing. Yeah, it's a good indicating that straight edge filler gauge, of course, it still have a certain minor percentage of it, and of course dial indicator, we have a right balance of it. It's perhaps it's time to perhaps move on. Yeah, you can move on to laser alignment after this, perhaps, right? So yeah, thank you, Robin, for facilitating this poll. It makes me it gives me a further insight of how things work. Right. So. And let's move to the next one. Yeah, so this is the evolution of our PRUFTECHNIK alignment. Yeah, as we mentioned earlier, the opto line, right? And the rotor line, after 10 years later, we have a double detector, right? XY. So means double detector means that
sorry, Keith.
Keith, are you showing your screen again? For some reason, it did not go back to you. So let me make sure that it's, for some reason, it didn't want to come back to you. So I'm going to stop the screen sharing, and I'm going to make you the presenter again. For some reason, it just didn't want to cooperate with us. So we'll give it just a second, and I will take it back to you.
No worries.
And you should see an opportunity to reshare.
Perfect. I'll be back.
And now we see your screen again.
Perfect. All right. So Okay, so just to just to repeat what I mentioned earlier. So if you can see the opto line on the left hand side and moving down the rotor line ultra, rotor line touch, and the opto line series. If you can see those jumps, right? If you can see those jumps in the years that we introduced our product, right? It's basically about 10 years differences, yeah, plus minuses. And of course, now it's, the last one being highlighted was the rotaline touch and the optaline touch, right? So the last one, when the touch series are being introduced to the market, was like 2015. And of course, this year is 2024. So perhaps let's fingers crossed, in 2025 year, we may look into some interesting things to be introduced to our majority of our attendees today, right? Which is already owning shaft alignment tools, right? So I do believe there's a big prospect, right, to look into perhaps new solutions or enhanced solutions to also bring up our adaptive alignment series, right? So okay, let's move next to after the evolution. Okay, so the adaptive alignment, right? So the adaptive alignment, let me brief you a bit, right? Is the next generation of laser alignment, where it's the sharp alignment users who can continue to to innovate in the field, where all these information such as how to make things smoother and how to keep your keep your measurements being done reliable, or even filtering off all those unnecessary or all those, I would say, unreliable data, right? So the adaptive alignment portion is able to uh, uh, utilize, right, this kind of action towards it, right? And how does it do it, right? It actually combines the hardware and software solutions by enabling maintenance teams to address every alignment challenges, from simple to complex, and challenges that our basic systems cannot handle, right? And of course, let's look at our adaptive alignment system, which is is able to adjust to the asset itself. How? I'll show you later in the next few slides. And to the alignment situations or challenges, right? For instance, couplings with coupled mode, or couplings with uncoupled mode. All these things we are able to adapt, right, to these kind of challenging situations. And also, to make things much more general, we can have basically untrained technicians, they can actually also able to use the device to complete their alignment task by just having this adaptive alignment portion to follow, right? Okay, so of course the goal of it is to eliminate what we call guesstimates, or all these guessing or wasted efforts, right? Wasted effort means that once you've done and you have to redo again. So what it means is that once you just run a first time portion, right, you are able to at least get a very reliable measurement, right? So the machine itself is able to filter off all those unnecessary data, as I mentioned earlier, right? So this is indirectly saving time, right? And of course, yeah, let's move how they're gonna do it, right? And there's two portions of it, which is the hardware portion, as you can see from the first one, which is our sensor line technology, right? We have our sensor line 3 in our shuffle line touch. We have a sensor line 5 in our opto line, and of course we have our sensor line 7 in our rotor line series, which is mainly the rotor line touch non-EX series, right? And of course, our EX portion will actually take on the technology of the sensor line 5. Yeah, but yeah, certain software portion, it has some additional features, right? That's why it's called the rotor line series. It's fall under the rotor line series for the EX, right? So the second portion of it is the software, right? or we classify as the active situational intelligence, or in short ASI, right? And these are the some of the features that I'm going to run through with you, right? Such as the simultaneous live move, the sweep, uncoupled features like the pass mode, sweep mode. No, sorry, uncoupled, of course, the pass mode, and of course the multi-point mode. Yeah, sorry. And we do have our freeze frame measurement, and we have our of course the thermal coverage, and of course I did mention before the ARC 4.0. Yeah, so what we are introducing to you is our latest rotorline series, which is our rotorline touch, right? And of course, what you can see here, we do have a few features to offer to our end users. We have a standard and have a full feature version. Our full feature version is including everything, which is the software, and also the mobility version, which is the Wi-Fi, RFID, which is the one that you can use for tagging. All right, you can tag on all your machines, and then you can just use your device to go and check an RFID to identify which kind of machinery or assets that you have already taken measurement of, and you can directly, without taking more time to search for the file, you can actually directly have the tag ready and just scan to it, and you'll get back the file pop up for you, right? So, and of course, we do have our camera version also, right? And yeah, so as per I mentioned earlier, these are the coverage, right? And of course, we do have our of course the mobility series. We do have our cloud enabled portion, yeah, right, which is you can do everything wirelessly, right? And with the Wi-Fi connected, you can always upload and download your measurements or your tasks, right, through the alignment device, right? And of course, this is what I meant. Okay, so if you have the software, which is ARC, you can always upload your work order up to the cloud, which is done by our PRUFTECHNIK, and it will be downloaded to the tools or device. If you're using your own personal hotspot, yeah, you can download it through this device, and you can send back the same results, right, after you've taken a measurement on site, and then you will be actually be able to download back to your software, which is back in your head office or your maintenance room, right? And of course, last but not least, also you have your direct connection. Sorry, is cable portion, right? Or even you can use your direct Wi-Fi, right? The same sub-network Wi-Fi, you can also do the data transfer. All right. Okay, so let me run through a bit of the adaptive kind of alignment samples, right? So for the sweep mode, right, we do have a sample to show you how the sweep mode works, right, in a live move, right, a measure and a live move. And if you can see here, right, this is just a compliment with Chris Wilson, right? He's the one that helped us to do the recording, so of this a quick demo portion. And if you can see here, measurement is done after the dimension is keyed in, right? And then you can go directly to the result portion of it, and just pause a while, and I'll just explain. With that said, right, after you do a quick measurement, right, one turn, and then straight away you're able to view the results in your device, right? And it tells you that, hey, you have perhaps your machine currently, it's higher, right? If you can see here 0.03 and 0.06, so what you should do, you should bring down your machine, right? And yeah, on this portion, we are referring to the correction results, and on the right hand side here, we are referring to the coupling results. Right, so the correction results give you a good indication of what you're expected to do in order to rectify your misalignment, right? And of course, the 0.26 and the 0.05 is referring to the movement of the motor away from you or nearer to you. And as you can see from the sharing, it should be moved nearer to you. Yeah. So on the right hand side is the motor portion, just to let you know. Yeah, on the left hand side is the pump. So the pump is usually the stationary one that you install with the laser, right? So this is how a sweep mode actually works. And then now moving to the live move, right? So yeah, our adaptive alignment, right? So we have a live move to show you that, you know, if your machine is moving, yeah, if you want to do the correction, this is what is being done. And you can see, yeah, the machine on the motor is being pushed nearer to you, right? And then indirectly, you will reduce the number in the screen, as you can see. That is the horizontal adjustment that's been done. Of course, I don't think there was a vertical correction being done there, right? Yeah, so after you have done the live move, the system requires you to do a finalized measurement, right? So again, you just perform the measurement again. And if you can see here, the movement starts from the red portion, turning to amber, and then turning to green, and then turning to blue. Yeah. So okay. You know, this I have a few questions from last participants last time, where what is this, right? So that portion shows you how reliable is your machine, right? So if the measurement is straight, right, you still maintain, you still need to go more, you still need to sweep more until it gets at least a yellow or green, right? And of course, after performing the final alignment, you can actually save the asset. Yeah. So all this will give you a quick a live move kind of a demo. And of course, this is just a quick one to show you how easy and how prompt the device works. Right. Then, of course, we have our coupling backlash. Right. So the coupling backlash, let me run through a bit. So our active situational portion will actually help you to eradicate coupling backlash issues, right? So this will actually give a user a very good advantage where when this kind of backlash is detected, right? When the measurement is done, also the coupling backlash is being those data is being actually removed or taken away. Yeah, so it only collects the good data, right? But it will inform users that hey, there's a coupling backlash. But nevertheless, measurement is done, and this is the results that's being collected. This is a bigger screen just to show you where the coupling backlash exists. Yep. So when you do your manual adjustments, right, you do not need to shut off the whole laser alignment, and you can just continue to perform your shaft alignment. Yeah, with that said. Okay. Yeah, so this is the bigger screen to show you how the coupling plate was detected. All right. Now, let's move next. All right. So for user issues, right? Yeah, we do have also a portion where we can cover the user issues, right? Yeah, this is just to simulate, right, whether your machine have is being purposely done wrongly, right? All the worst possible ways that you are able to collect bad data, right? So in fact, at the end of the day, what I'm trying to show you is that you are having a live indicator of how you should go slower, you should move faster, you should all these are shown there. Yeah, to tell you that your machine is actually this kind of a process is having this a lot of issues, right? And yeah, this is what we are highlighting about the um, active situational portion, right? ASI, intelligence, right? Yep. And of course, let's move forward. For rotatable and uncoupled shaft, right? Okay, this is uncoupled but rotatable. Yeah, we are actually able to use a next portion, which is the pass mode, right? And if you can see, the pass mode is done just instantly. Our machine, when it passed through, yeah, because of the shaft, both of the shaft can be rotated, but need to be uncoupled. That's where you can apply this mode. Now, sometimes why are the coupling being removed? Reason is why when you are having normal operating like cold condition, right? Perhaps your shaft is bent, right? You're not sure about it because we have two different materials, but you have to factor in, and then you have to put in a removal of the coupling so that you can have a better actual measurement of your coupling. So this is the result, and yep, and it's the same thing as for the sweep mode. All right, you can do your rectification from there onwards. And of course, for the multi-point is for non-rotatable shaft, such as a sleeve bearings, right, or a wide baby bearing, right. So you can have a sliding bracket on the right-hand side, which is the sensor portion, and then you can start your measurement. Yep. Let me move quick a bit due to time constraint. This is what the pass mode works. So it just pass through each other time by time. And this is the mode that's being changed from this portion. Yeah, you can change all your mode from the center point here. Yep. And it all collects the data within a gauging within ±1 degree. Yeah. So it's remember, once one of the shaft is not able to rotate at all. Yeah. So this is where we come up with uncoupled. We call it the multi-point intelligence, right? All right. Now let's move next. Yes, this is just to show you a quick one how the shaft is being collected, right? The measurements. So all focusing on the measurement. So once it's fall within the degree of ±1, and then it will collect a measurement automatically. This all can be done through the setup of the device. All right. So we have a freeze frame. The next one is if you have a coupling with a very bad misalignment, we can have a freeze frame mode, or we call it extended mode. Yeah, indirectly. Yeah, if you can see there, the device will detect whether your laser is ending, let's say 75% of the sensor portion, right? So when nearing to that outside to the sensor, you will prompt this indicator, and then you can do your adjustment directly to your device without even switching off your machine, right? Then you can just directly do the adjustment, continue with your measurement, and the data is collected straightforward from there also. Right? So this is a quick one to show you how it's adjusted, and then when it's centered, then you can continue your measurement. Right? Right. So yeah, just to save time, right? We can move forward to just to summarize how our adaptive situational intelligence work. Right? So yeah, for coupled and rotatable machine, right? Overall, we will use our sweep measurement mode, and for uncoupled rotatable, we can use our pass mode, and of course for uncoupled and non-rotatable, we can combine it with our sliding bracket, and of course we will use the multi-point version. All right. And yeah, so the user benefit, right, of it is that give us quick decision making, and of course it gives you live guidance, right, to actually go faster, go slower, and all those indicative coupling pace and all those stuff will be actually projected to the customer, right, or to the end user, right? So yeah, so we have a few more to cover, but of course, just to run through, we have our multi-coupling. You can our rotor line can take up to six couplings, right? 6 coupling measurements, right? This is how the whole portion is, but of course you can get the slides to show you all the videos. But yeah, just to run a quick one, yeah, this is how the multi-coupling setup is, and how both couplings are being set up. And of course, when you look at the results, when you turn it, yeah, these are the results as per both coupling. And of course, this is the live move for the coupling mode. Is all you can combine both sensor line 7 and sensor line 5 to run at the same computer unit together, right? So I believe time is running out. So yeah, the last portion I just want to highlight is that the thermal growth. Yeah, so just to have it quick for you all to take a look. In fact, our laser sensor line 7 is able to take up the thermal growth information. And if you can notice that the coupling is actually it's not coupled together with the bracket. Yeah, it's actually mainly attached to the body of the machinery. So what happens is that this thermal growth is to collect the growth of the machinery, yeah, based on when the machine is running. So it's not supposed to be coupled on the shaft itself, right? At the end of the day, the demo session is just to simulate by using the laser to simulate, all right? And then from time, right, movement, yeah, you can collect and you can obtain, what we call the target values, coupling target values, right? Yeah, so at the end of the day, you're able to find a result which is computed and provided to you as the real situation of your machine thermal growth, right? So this is where the thermal growth coverage works. All right, so yeah, just to summarize for the adaptive alignment, right? So multiple coupling can be done on our asset horizontal, coupled, uncoupled. And of course, it gives you speed, as we mentioned earlier. And of course, the thermal coverage will give you a horizontal machine alignment for complete machine train. And of course, it gives you measure and log simultaneously the movements of the thermal growth of the machine, and automatically record the machine train changes to determine the presets of the coupling and machine feeds, right? So the benefits are the same as per above, right? So yeah, at the end of the day, adaptive alignments give you two major innovations, which is in the software and hardware, as we mentioned earlier, in the technology of sensor line, and also the ASI, active situational intelligence. And of course, we have we support broad range, which is from critical rotating assets, and of course to solve alignment challenges. And of course, every alignment users or technicians can use it as a pro. Yeah. So the last question is, right? Yeah, just to save time. Yeah, there's a poll question to ask if the alignment. How do you find the value in the alignment system that adjusts based on the situation and user expertise? Yeah. Do you find value in it? Yeah. Is it beneficial? Is it moderately beneficial? Not very sure, unsure, or we currently don't have alignment system? Yeah, please just do a quick poll. Yeah, thank you. I'll pass it to Robin.
And the poll is running now. We'll give everyone just about 60 seconds to answer the poll.
Thank you.
And Keith, while our audience is answering the poll, I know that we're up against time, but do you think we'll have time for me to just randomly choose one of the questions and have you answer it?
Yeah, perhaps one will do.
Okay.
Or maybe you can chip in two if it's not
the
too.
poll.
Yeah.
The poll will be done in about 20 seconds. All right, I think most have voted in the poll. I'll share the responses. So as you can see, 71% found it was very beneficial. And I'll hide the poll now, and it should go back to you. Oh,
Okay.
it cooperated this time, Keith.
So does it? Yeah. Can you see the screen?
We can see your screen again. It did work this time.
Perfect. Wow, perfect. Yeah, so it seems that from what I see from the poll, yeah, I thank you all for also giving a time to absorb our adaptive alignment sharing, of course. Yeah, and yeah, I hope that you all, as per mentioned, find it beneficial. And of course, we can share you the slides for you to do a further reading. Yeah, if you have any questions, you can obvious can write back to us, and we can answer that yeah, after this session, right? And of course, yeah, I would just like to extend just a few seconds on what I want to share in the extended warranty. just a few seconds. So we have this kind of a program. We can extend our basic warranty from basically 2 years for shaft alignment to 5 years. So it means 3 years additional. So this is our extended warranty program that we are offering to our customers, right? You can acquire prior to closing the order, yeah, or if you want to add on to your purchasing, right? And of course, to maintain the systems, of course, you have to protect it from fluid and dust, because basically the sensors and laser portions are very important, right? And it must be cleaned thoroughly, right? And of course, having trained professional, and always, if you are in doubt, refer to operating manual is always an important thing, right? And also one last thing to be touched by trained professional, obviously. And of course, for the professional calibration services, we have calibration locally. And yeah, feel free to reach back to us every 2 years to do a regular calibration checks, right? And of course, we have, as promised, we'll close up with these academic training courses. Of course, we have our Mobius trainings, and of course, we have our Fluke in-house trainings. Yeah, so this is how our training courses have shaft alignments, ranging from and shaft alignment to vibration analysis. And of course, we have our own in-house level 1 and level 2 vibration analysis, and also the new course that we have introduced not too long ago, which is the field balancing, in which they are actually having it today live in our office, right? So anyway, yep, thank you so much. And if you have a question, please throw in now. Yep.
All right. Keith, we have time for one question, so I'm going to choose one and ask you if you don't mind. And the question is, what is the best technique of conducting alignment on motor and gearbox with fluid coupling? So let me say that one more time. What is the best technique of conducting alignment on motor and gearbox with fluid coupling?
With fluid coupling.
Yeah, fluid coupling, yes.
Okay. Correct me if I'm wrong. If the fluid coupling, which means if it's okay, I'm not going guesstimates, but I assume that it is a short flex coupling, perhaps. Oh, okay, sure. Hi. Yeah, I have Gav around. Yeah. So, sorry. I think hold on. Sorry, Robin. Robin.
Yes, I'm still here.
Yeah. Sorry. Can you repeat yourself again? Sorry, I missed out.
Yes, absolutely. What is the best technique of conducting alignment on motor and gearbox with fluid coupling?
Okay, so I mean, of course, the best technique to use is laser alignment. Yeah. So as per mentioned, right? So of course, because the reason why is that it provides you the high precision, speed, and of course setup, right? Because this is considered complex, right? So this complex component requires, I think, our shaft alignment can be able to perform this, and I do believe because it's coupled, you can directly use the sweep mode. Yeah, the sweep mode, which is I've demo earlier just now. Yeah, so I hope that helped to answer. And of course, one last portion to add on to your question is that if there's a soft foot required, especially before the alignment is done, yeah, you can also use our function from the Rotating Touch series. Yeah, so yeah, that will be it. I hope that answers.
All right. Well, thank you, Keith, for a great presentation. And to our audience, thank you for joining us today and sticking with us for a few extra minutes. As a quick FYI, when you exit GoToWebinar, there will be a window that pops up with a very short 30-second survey. We would appreciate your feedback on today's session. Thank you, everyone, for joining today. Thank you, Keith, for your expertise, and I'll close the webinar now.
Thank you.